Okay, so another application of exponential functions is what we call compound interest, okay? We're going to be dealing with two formulas for compound interest. One, this first one right here, is when we're compounding over specific periods of time, okay? Annually would mean once per year, quarterly would mean 4 times per year, daily we would call 365 times per year, okay? The others, if we're compounding what we call continuously, all right? And if we compound continuously, we're going to use this formula that you can see the number e here as the base of the exponential part, okay? So let's just kind of define what all these variables stand for. So A is the amount of money you have after a set number of years, okay? P is the principal, which is the amount of money that's invested initially. Now, we're not going to add to our investment in this example. We're just going to put money into an account one time, and we're going to calculate how much is there after a certain number of years using these other variables, okay? R is the interest rate. Now, you can't use percentages in formulas, okay? So you're going to have to convert that interest rate to a decimal. You can only use decimals as your interest here, not the percent. N is the number of times we're compounding per year, okay? Annually, again, would be 1, quarterly 4 times, etc. N is the, already just covered that. And the T here is the number of years, okay? With compounding continuously, again, we use the A, we use the P, we use the R and the T. Okay, notice the N is missing from this formula because we're not compounding over a specific period of time, okay, or specific periods of time, but we're compounding continuously. So N is not necessary here, okay? All right, so let's say we're investing a sum of $1,000 and we're going to earn 12% interest per year. Now, that's a really high interest rate, okay? But this is just an example that we're dealing with, all right? So we want to find the amounts in the account after 3 years for all the different types of ways that we could compound. So annually, semi-annually, etc., okay? So we want to make sure we're using the correct formula, all right? So annually, this is what I've got. So the A is going to be the amount after 3 years. Our principal is $1,000. Our interest rate was 12%, which we have to convert to 0.12, all right? We're only compounding once per year because it's annually, so n equals 1, and we're doing this over a period of 3 years, okay? So t is 3, all right? So we're going to write our formula down, and we're going to plug in the values that we know, okay? And we're solving for A here. How much is in the account after 3 years, all right? Your biggest issue here is going to be making sure you follow order of operations correctly and plugging that into a calculator correctly. So we've got grouping symbols here. So I'm going to do that first. So 1 plus 0.12 over 1 is 1.12. Okay, 1 times 3 is 3. All right. So exponents come next. So I'm going to do 1.12 to the third power, which gives me 1.4049. All right. And then I'm going to multiply by 1,000. All right. So I've taken this out far enough that I can round to the nearest cent because we're talking about money here. So when I multiply, okay, after 3 years, just compounding annually, once per year, I should have $1,404.93, okay? So just compounding the once per year, I would have this much money after those 3 years, okay? The more often you compound, the more interest you would earn, okay? And let's show that with the next example. Okay, so let's go to semi-annually. So all our variables are staying the same except for n because we've changed the number of times we are compounding, okay? So semi-annually means once every 6 months, okay, or twice per year. So that's why n is 2, okay? So we've got our formula. I'm going to plug in all my values. Again, I'm solving for A, okay? Order of operations, parentheses first. So that gives me 1.06. I can go ahead and multiply this. There's no reason I can't make that a 6 already, okay? Evaluate the exponent. That gives me this value, okay? Again, I want to take it out far enough that I can round to the nearest cent, and then I multiply, okay? So if you remember, if we compounded annually, we earned, this much money over 3 years, $404 and change, okay? If we compound semi-annually, we actually make a little more money, okay? So after 3 years, I would have $1,418.52, okay? Okay, so pause the video right here and try to do the compound interest if we're doing that quarterly, okay, which means once every 3 months. Okay, there's 4 quarters in a year, so every 3 months, so the number would be 4. And monthly, obviously there's 12 months in a year, so n's going to equal 12. All the other variables remain the same, and we're still solving for a. So pause the video here, give both these a try, and then come back and check your work. Okay, quarterly, again, there's 4 quarters per year, so that means we would be compounding 4 times. All right, so let's use our formula. Okay, we're going to plug in what we know for P, R, N, and T. Okay, and we're solving for A. Okay, so again, R has to be a decimal, 0.12, N is 4, and then up here at the exponent, we've got 4 times 3. Okay, so let's simplify here within the parentheses. It's going to be 1.03. 4 times 3 is 12. Okay, so now I'm going to evaluate the exponent here. So that gives me 1.425761. Okay, multiply that times 1,000. So after 3 years compounding quarterly, we should have $1,425.76. Again, compare that to the biannual one. We're making a little more money because we're compounding more frequently. Okay, it's not a huge amount of money, but it's still more money. Okay, and that matters. All right, so let's give monthly a try now. Okay, again, monthly means n equals 12. All right, so let's go through the process here. We've got our formula. Again, we're still sticking with that formula because we've got a specific period of time here that we're dealing with. Plug in our known values. Okay, order of operations now. Parentheses. Okay, when I add these together, I get 1.01. This simplifies to 36. Evaluate 1.01 to the 36th power, which gives me 1.430769. Okay, and then multiply that by 1,000. So if we're compounding monthly, we're going to make have $1,430.77 after 3 years. And again, you continue to see we're having more money in our account after 3 years when we're compounding more frequently. Okay. Now daily, obviously we've got 365 days in a year. Don't worry about leap year. Okay, we'll do 365 here. Our answer should be bigger than 1430. Maybe not much. Okay, but again, we should have more money because we're compounding more frequently. Okay. The only change is n equals 365 here. We've got our formula, plug in our known values. Simplify in the parentheses, simplify my exponent. Okay, that gives me 1.000329 to the 1,095th power. Okay, evaluate the exponent. That gives me 1.433244. Multiply that by 1,000. So after 3 years compounding daily, I should have $1,433.24. And again, you see an increase because we're compounding more frequently. All right. Now pause the video here. Try to use the other formula, the A of T equals P times E to the RT. All right. And try to calculate continuous compounding, how much money you would have if you did that. Okay. And then come back and try that. So finally here, we're going to use the formula that has the number E in it. Okay. Because we're continuously compounding. So we use the A of T equals P times E to the RT. I don't need N anymore because it's continuous compounding. My other values, they're going to stay the same, okay? And I'm still solving for A, okay? So plug in what we know. Again, E is a number, so I don't have to substitute 2.718. You're going to use a calculator to evaluate that here in a second, okay? Order of operations, I have to evaluate this exponential piece first. Okay, so I'm going to simplify the 0.12 times 3. Now I'm going to evaluate e to the 0.36, okay, which gives me this value, 1.433329. Multiply that by 1,000. So with continuous compounding over 3 years, that $1,000 should turn into $1,433.33, okay? Again, the more often you compound, the more money you make. Now, going from daily to continuous, notice there's not a huge change from 1433.24. We're only getting 9 more cents, okay? So it's not a huge difference. But that's how you use exponential functions to calculate compound interest.